So what we're going to have a look at today is angles that are associated with parallel lines. First thing we need to know is that when we have two lines and it's cut by another line, then that's called a transversal. So we have two straight lines here and another straight line that cuts those. That's known as our transversal. We should notice though, remembering that when two straight lines cross, our vertically opposite angles are equal. Same with these two straight lines, our vertically opposite angles are equal. It's important we remember that. So, why is it so important? Well, when these two lines are actually parallel, there's something special that happens with the angles. Many angles are actually equal. So as we said, our vertically opposite angles are equal. And our vertically opposite angles are equal. So here we go. Our vertical opposite angles are equal. And in fact, this angle here is the same as that angle there. And that only happens when these lines are parallel. So they will tell you that they're parallel, or they'll actually have arrows on there facing the same direction to indicate that. Now my diagrams don't actually have that, but they'll have arrows indicating unless they tell you otherwise. So when the lines are parallel, these angles and these angles are all equal. Also, these angles and these angles are all equal. We also have some angles that are supplementary. So these ones that aren't equal, they're on a straight line there, they will add up to 180. These ones on this straight line add up to 180. So we can see that the ones that aren't equal are actually supplementary because of the straight lines and the work we did with supplementary angles in our last video. Now we need to look at some special types of angles that are formed with the parallel lines. The first lot is what we call corresponding angles. And corresponding just means matching. So when we're talking about corresponding angles, they're in corresponding positions or in matching positions. So if we have a look here at these two lines when they cross, this angle that I've marked already is in the top left side of that intersection. Then if I have a look down at this intersection, this angle here is also in the top left part of that intersection. So they're in matching positions or corresponding positions. So they're known as corresponding angles. And when these lines are parallel, those corresponding angles are actually equal. But it only happens if the lines are parallel. If these two lines were not parallel, like in our first diagram that I showed you, then those angles are not the same. So with those lines being parallel, we get some special things that those corresponding angles are equal. So here's another pair of corresponding angles. They are equal. Another pair of corresponding angles. So they're in matching positions or corresponding positions. They are equal. And we have another pair. So four pairs of corresponding angles, and they're all equal. So that leads us to another type of angle that's formed with parallel lines, and these are what we call alternate angles. So alternate means they alternate or on different sides of the transversal, but they're between the parallel lines. The corresponding we're not between, but with our alternate angles, the angles we're looking at are actually between the lines there, the parallel lines, and they alternate from one side to the other of the transversal. And we find that alternate angles are equal. So these angles, excuse me, these angles that alternate from one side to the other are actually equal in size. And we have another pair of alternate angles, and they are equal in size also. So that angle equals that one, and we just saw a moment ago this angle here equals that one. And you can look carefully with our parallel lines and say, yep, that one looks about the same size as that if you forget. And this angle looks about the same size as that. But remember, it only happens when those lines are parallel. So the next or third type of angle we need to look at is what we call co-interior angles. Now, co means together, interior means inside. So we're looking for angles that are together on the inside. So they're between the parallel lines, that's what we mean by inside, and together meaning on the same side of the transversal. Now you'll notice that this angle here is acute, and this angle here is obtuse. So there's no way that they can be equal, but in fact, because the lines are parallel here, these angles are supplementary. Okay, so co-interior angles are supplementary, and remember that means adds up to 180 degrees. And we'll find the same on the other side here. So here's another pair of co-interior angles. They're between the parallel lines and on the same side as the transversal. So again, they are supplementary. So let's have a look at some examples of what we've just learned. Find the value of alpha. So I've used a different symbol apart from theta, but it's just a symbol to use that I don't know that angle yet. And you'll notice here I've got giving reasons, not just working, but giving reasons. So we need to recognize that we have an angle here that is at the top left intersection, and this angle here is also at the top left intersection. So they are corresponding angles. And because these lines are parallel, then these corresponding angles must be equal. So I can say that alpha is 72 degrees, but I haven't given a reason yet. And this is just as important as getting the answer itself. So the reason I need to put next to it is corresponding angles with parallel lines. So I know that alpha is 72 degrees because they're corresponding angles, but they're only equal because of the parallel lines. So if these lines are not parallel, then these two angles are not equal. So if I forget that parallel lines part, then I'm not showing that I understand properly why those two angles here are actually equal. Example 2. I've gone back to theta. I want to find the size of theta, and again, giving reasons. Well, I notice that they're both between the parallel lines, so they can't be corresponding. And they're on the same side as the transversal. So that means they are co-interior angles. So what do I know about co-interior angles? Well, they must add up to 180 degrees. So the two angles added together must be 180, so they're supplementary angles. And if I subtract 47 from both sides, I will get the answer. However, I haven't given my reason. So I can say that they must add up to 180 degrees because they're parallel lines and co-interior. So let's write that down. Co-interior angles with parallel lines. Remember, they do not add up to 180 unless they're with parallel lines, so that's important too. Now subtract 47 from both sides, and I find that my missing angle here is 133 degrees. So let's move on to the third example. Again, let's find the missing angle, giving some reasons. So here's my angle. These lines are parallel, even though I haven't said so in the question, they're parallel. The two angles here are between the parallel lines, but they alternate. They go from one side of the transversal to the other, so they're alternate angles. So what do I know about alternate angles when these lines are parallel? Well, I know that they're equal. So these two angles are the same, but my reason, alternate angles with parallel lines. Okay, remember they're only equal with the parallel lines, so I need to have that part. And that's example 3. So let's move on to example 4. Again, let's find theta. Find this symbol here, giving reasons. Well, they're not both between the parallel lines, so they could be corresponding. However, this is at the top right intersection here, or the top right part of the intersection, and this angle is not part of the other intersection. So I can't use corresponding angles either. However, if I forget this line here, So I'm going to try and forget that line. It's a bit hard, but what I'll do is I'll cover it up so it's easier for you to see. So I'll try and cover that up. So now I've got two straight lines that cross. What do I know about the opposite ones? Well, our opposite angles are equal. So we call those vertically opposite angles. Now I wasn't using the parallel lines this time because I covered this one up. I was just using the fact that these two straight lines, when they cross, the opposite angles are equal, called vertically opposite. So sometimes we're given more information than we needed. So we just have to be a little bit careful of that. That moves us on to example 5. A little bit more complicated. I've got some letters here to indicate the points that I might need to refer to. So the question says, if AB is parallel, now that symbol, the two lines there, means it's parallel to. So if AB, there's my AB, that line there, is parallel to CD, so I know the question's telling me that these two lines are parallel. I want to find the size of angle FGD. FGD. So I'm trying to find the size of this angle. And I know that angle EFB is 57 degrees. Well, let's make it a bit easier for ourselves. That's the angle I'm trying to find. And that's the angle that I know up here. And if you look at them, they look the same size. So I'm going to write angle FGD is 57 degrees. But why? Well, they're parallel lines. They're not between the parallel lines. So they can't be alternate or co-interior. That's at the top right intersection. That's at the top right intersection. So they're in matching or corresponding positions. So they're corresponding angles. And remember, when these lines are parallel, and it actually told us in the question, then those corresponding angles are equal. Now you notice that instead of me writing with parallel lines on the end, because I actually know which lines we're talking about, I can shorten that a little bit and say because AB is parallel to CD. So it looked a bit more complicated, that question, because of all the extra information given to you, but it's just as simple as what we've done before. So they are angles with parallel lines, the three different types: alternate angles, corresponding angles, and co-interior angles. Remember that it's important that we're looking at them with parallel lines.